Chapter 11, Integration, Section 11.8, finding the areas under the curve or between two curves using integration. So example 22 has got a diagram showing the curve 9 over root 4 plus 3x, and then you are told that the region R is bounded by the curve, the x-axis, and the lines x equals 0 and x equals 4. So here's our region R. And you've been asked to use integration to find the area of that region. So it's area under the curve, so you really have to be integrating the function y between the two limits 0 and 4. So that's going to be our area. So let's replace our y with the function, and we're going to bring it straight to the top and give it a power of a minus a half. You might recognize straight away if a linear bracket is replaced what x is, you can do a quick chain rule. So I'll do it this way. So if I'm thinking, can I integrate 9x to the power of minus a half? And the answer is yes. You add 1 to the power, divide by that power. So here, because the x has been replaced by the linear combination of x, we can just apply the same rule, add 1 to the power, divide by that power, but then we need to undo the quick chain rule, so divide by 3 as well. So it's going to be 9 times 4 plus 3x. Let's add 1 to the power, so to give me a half. And then we're going to divide that by the new power. So it's going to be divided by a half, and then divide by 3. So effectively, both a half and 3 will be in the denominator. Okay, you might want to tidy it up. The 9 divides with 3, and you will be flipping the half, so you will have 6. Or since you're putting the limits in, you could just put the limits into the expression as it appears. So not risking making any mistakes, you just use a calculator to find the value of that. So either do it like that. There you go. So that's the top limit minus the bottom limit. There you go. Or you could have tidied it up, and that would be 9 dividing by 3 over 2, which gives me 6, 4 plus 3x to the power of a half, and then put your limits in to that. There you go. So this will be 3 times, that's 16 square rooted, which is 4. 4 times 6 is 24. You do it with a calculator, by the way. This is 2 times 6, which is 12. So the area should be 12. There you go, square units. If you have a complete blank and you forgot that it could be a quick chain rule, in this situation, as I've shown you in the previous videos, what you could do is replace the awkward part, so the part that gives you that gets a weird power, with a u. So use substitution. So if you let 4 plus 3x be replaced by u, du dx is going to be 3. So du is equal to 3 dx. So it's a third of du is dx. And you're ready to do the substituting. So over here, since we are going to integrate this, you're going to have 9, and then it's going to be square root of u, and then a third du. So it's going to be 3u to the power of minus a half that needs to be integrated. So add 1 to the power, divide by that power, so it's 3u to the power of a half over a half. Now the limits needs to be changed. So over here I need to find what u is when x was 0 and what u is when x was 4, because these were the old limits. So when x is equal to 0, u is given to be 4, substituting that into there. And when x is equal to 4, u is going to be 4 plus 3 times 4, so it's 16. There you go. So you could see that a half, 3 over a half is 6 times 16 to the power of a half minus 6 times 4 to the power of a half. And you could see that it's 6 times 4 minus 6 times 2, it's 12. So you may have chosen this method. Okay, so example 23. Now, we've met the idea of finding the area trapped between a curve and a straight line in year 12 maths. Now, in this course, in year 2, you might need to find the area trapped between two curves. The idea is exactly the same. So over here, if you just imagine taking scissors to this picture, you'll be cutting out along the y equals sine 2x and the x-axis. You'll cut out this hill, and then out of that hill you neatly cut out the other hill, which is the integral of that function. So what we really need to do is find two areas. So area A, that would be area of the sine, and then we'll find area B, so that's going to be the area, that smaller area, and then we'll do A minus B. So this is the integral of sine 2x between the limits of 0 and pi over 2. And this one is the integral. Again, the limits are unchanged because these are the 2 points of intersection of the two curves. And we are integrating sine x cos squared x dx. So let's do the first integral. So area A, that will give me, if I integrate sine 2x, sine integrates to minus cos. Remember to divide by 2, so it's minus a half cos 2x. Pop the limit in. So you're going to have minus a half cos of 2 lots of pi over 2 minus a half of cos 0. So it's minus cos pi is minus 1 plus a half times 1. So it's a half plus a half, which is 1. So let's look at area B. This time we've got to integrate this function here. So let's use substitution. So let's replace cos with u, because that's the one that gets higher power. So du is minus sine x dx. Sorry, I've jumped it quickly. Du dx is equal to minus sine x. And now you can separate it. So minus du is sine x dx. The reason I've done that, because I could see that I've got sine x times dx here. So all of that can be replaced with minus 1 du. Okay, so let's sub these in. So you've got sine x dx will form minus du. So minus 1 du, let's put minus 1 so it doesn't stop us from getting it right. And then cos is u squared. So it's going to be minus u squared du. So we are going to add 1 to the power, divide by that power, so it's this one. However, the units need to be sorted. I need to find what u is when x was 0 and what u is when x is pi over 2. So u0, you go over here, it's cos 0, which is 1. u of pi over 2 is cos pi over 2, and that's 0. Got them the wrong way around. Apologies. The bottom one was 0. On the bottom, and the top one was. Okay, so let's put minus. It's a bit weird because we're putting 0 here, but that's okay. We want to get the positive answer, and we will get it because there's a minus here, so that's fine. So that's going to be 0's cubed over 3, so it's 0 minus, and then 1 here, minus 1 cubed over 3, which is a third. So this one will give me minus minus a third, so it's a third. So the overall area is going to be 1, that's your area A, minus area B. So it's 2/3 square units. Good, so now we've got one more example to go through.